So today we are talking about the greenhouse effect and also climate versus weather. So it starts our unit on global climate change. So the 4 really important things that you should be able to know and do by the end of this video, plus the classwork we're going to do, are right here. So you need to be able to differentiate between weather and climate. So that means tell the difference between, explain and illustrate the greenhouse effect, list the 4 major greenhouse gases and their relative importance or their relative impact on global climate change, and also use a model to describe how variations in the flow of energy into and out of Earth systems result in the changes in climate. So that's what we'll focus. We're going to get a little bit of background today in the video, and then tomorrow in class we will focus on creating this model that we will need. Alrighty, so one down. Alright, so we have weather versus climate. So weather is the day-to-day atmospheric conditions that we see with regards to temperature, precipitation, wind, and humidity. So basically this is like what is happening outside right now. And then climate is the average atmospheric conditions. So we're still talking about temperature, precipitation, wind patterns, and humidity, but over a really long period of time, like decades, so tens of years, or like even longer. And so climate is a much, much longer average period of the weather. So climate is driven by the energy from the sun. And then it's influenced by interactions with the atmosphere, water, and living systems, also known as ecosystems. Alrighty, moving on. So we have, so let's start talking about the greenhouse effect. So the first thing we need to remember is that energy from the sun travels to the Earth via electromagnetic radiation. And so this is traveling in waves to Earth. And so this incoming radiation is called insolation. So the amount of energy that comes into the Earth's atmosphere is called insolation. So some of that energy that comes into the Earth's atmosphere is reflected by the atmosphere and clouds and other reflective surfaces like ice, and that's called albedo. So when like ice bounces the light energy back up into the atmosphere, that's called albedo. And then so that's just a small fraction of it, but most of that energy is absorbed by land and water surfaces. And so that energy that is absorbed, about half of that is used for warming the surface of the Earth and the water. And then the other half of that energy is re-emitted as infrared radiation. So then that infrared radiation that has been re-emitted by the surface of the Earth, then some of that passes through the atmosphere and goes right back out into space. But then some of that re-emitted infrared radiation gets trapped by greenhouse gas molecules. So the infrared radiation is trying to leave, and the greenhouse gas molecules block it. And then they reflect it, re-emit it in all different directions. And so that energy comes back to the surface of the Earth and stays in the troposphere. And so that process warms the troposphere, which is the layer of the atmosphere that we live in. It's the one closest down to the bottom of the Earth. And that's what we call the greenhouse effect, is when the infrared radiation that's being re-emitted back out into space gets blocked by the greenhouse gas molecules and then gets re-emitted back down onto Earth's surface. Okay, for the most part, we like the greenhouse effect. It's our friend. It helps us live here because there are not enough winter clothes in the world that would allow you to live on planet Earth if we did not have the greenhouse effect. So the greenhouse effect is good for the most part, because it makes Earth warm enough to support life. So that's a good thing. It helps us be here. It's not a great thing when we start adding way too many greenhouse gases and it kind of goes out of control and we have too much warming. So we'll start talking about that in steps. But right now, you need to know the 4 main greenhouse gases. So these are the gases that are trapping that infrared radiation that the Earth's surface is emitting and trying to leave, but it's not, the greenhouse gases aren't letting it. So the first one is water vapor, good old H2O. The second one is carbon dioxide. In 2012, carbon dioxide was about 82% of all of the greenhouse gases emitted in the US. So that's a lot of carbon dioxide. The main source, the main way that we produce carbon dioxide is by burning fossil fuels, especially for transportation. And then, so in the US and across the world, carbon dioxide emissions are going up quite significantly. And then our third greenhouse gas that we don't talk about quite as much as we talk about carbon dioxide is methane, or CH4. And methane is about 25 times more powerful of a warming agent than carbon dioxide. So for an equivalent weight or an equivalent volume of carbon dioxide and methane is going to trap 25 times more heat. So where does methane come from? Well, some of it naturally comes from wetlands, and that's only about 40%. And that's methane that our atmosphere is used to dealing with, and there are processes to recapture it and to keep a balance. But then there's about 60% of the methane that comes from human activities. So these activities are things like keeping livestock, as my awful cow drawing, and landfills. Remember once the garbage starts decomposing, the methane kind of leaks out the top and they have to release it or else it'll explode the whole landfill. Burning fossil fuels and coal mining. And overall, methane emissions in the United States are decreasing a teeny weeny bit. Not a very significant amount, so they're kind of holding steady, but maybe decreasing a teeny weeny bit. And then we have nitrous oxide, or N2O. So nitrous oxide is about 300 times more powerful of a greenhouse gas than carbon dioxide. So if you have equivalent amounts of carbon dioxide and nitrous oxide has 300 times the warming power. So the main source of nitrous oxide is from agricultural fertilizers. So applying those synthetic chemical fertilizers to fields, that's where it usually comes from. And emissions are actually increasing in the US, but just a teeny weeny bit, because we're using more, because we're trying to grow more food. So, alrighty, so there we have it. So now you should be able to differentiate between weather and climate, explain and illustrate the greenhouse effect, we'll get to that a little bit more tomorrow, list the 4 main greenhouse gases and their relative impact on global climate change, and then we have some modeling to do tomorrow. Alrighty, I will see you in class tomorrow.